Okay, so yesterday, okay, we were talking about how you predict the products of a chemical reaction, right? So what I want to do now is just write down the steps that you should follow for each reaction that you encounter, okay? What things you need to do, all right? So, predicting the products of a reaction. Okay. First thing we have to do, we have to have the reactions, reactants, written out in formula form. Okay, we cannot predict the products of a reaction with a word reaction. Right? So our first step is, and we haven't done this yet, we haven't had a word reaction given to us yet, we worked just with the formulas yesterday. Okay, but the first step is to write out the reactant formulas. Okay, so as an example, that might look like this. If the reaction I was looking at would be, let's say, chlorine reacts with iron 2 oxide. Okay, so that would be my first step. Okay, if I was given that word reaction, chlorine gas reacts with iron 2 oxide solution. Right? I would write out the reactants like that. Now, when I write out those reactants, I need to make sure that I've done two things that I just did subconsciously. And you'll get to that point. Okay, you'll get to the point where you don't even think about doing this. Okay, but one of our reactants was chlorine. I automatically put a 2 on that. So is that something I need to check in my head? Or more accurately, on my periodic table? Okay, is chlorine a special element? It is. That's things we got to look for. Okay, so I knew right away that chlorine was a special element, so I wrote the 2. Okay, and then our other reactant was iron 2 oxide. Okay, is this, what kind of compound is this? It's ionic. What do I need to do with all ionic compounds? I need to drop and swap. Okay, so this reaction would have looked like this. It would have said chlorine gas reacts with iron 2 oxide solution. Okay, so I would have looked at that and went, okay, chlorine gas, Cl2. Okay, iron 2 oxide. All right, that tells me the iron is the 2 plus iron, and the oxygen's always minus 2. Okay, those cancel each other out, so this compound is good the way I have it written. Now I have the reactants written out in formula form. Okay, that's step 1. Step number 2. Identify what type of reaction is occurring. Okay, so in the reaction that we have up there, I have chlorine, which is an element, reacting with iron 2 oxide, which is an ionic compound. So what kind of reaction am I looking at? This is a single replacement reaction. Okay, so there's step 2. I've identified that this is a single replacement reaction. Okay, then I've got to do step 3. Okay. Okay, using the reaction pattern. So now that I know this is a single replacement reaction, I'm going to follow the pattern that a single replacement reaction follows to make my products. what do we mean by that? Well, what happens in a single replacement reaction? In a double replacement reaction, the metals switch places. But in a single replacement reaction, we don't always have two metals, right? In this case, I have an element, could be metal or a non-metal, reacting with an ionic compound. So in a single replacement reaction, whatever the element is will replace the part of the ionic compound that it's like. Okay? In this case, chlorine is going to replace whom? The oxygen, okay? Because chlorine is a non-metal, and so is oxygen. Okay? So now I've gone through the pattern of a single replacement reaction, and I've determined that on this side of the reaction, iron is going to be with chlorine, and oxygen is going to be by itself. Okay, anything wrong with what I have written there? Yeah, I haven't checked for special elements, nor have I swapped and dropped that ionic compound that I just made. Those are steps 4 and 5. Okay, so step 4. So all I do in step 3 is put things where they're supposed to be. I don't even care if they're right yet. Okay, just that these two go together, this one's by itself, or these two go together and these two go together. Okay, all I do is write out who's who in the zoo. Okay, then I'll worry about the other stuff. Okay, so in step 4, okay, I would drop and swap any ionic compounds that are formed. If I don't have any ionic compounds being formed, which is possible, then I don't have to do that step. Okay? In which 2 reaction types would I not have to do this step? We went over 2 types of reactions that would not result in an ionic compound being formed. Combustion reaction, okay, makes carbon dioxide and water, both molecular, so I wouldn't have to do it in that reaction. And what's the other one? Decomposition, yeah. Okay, in a decomposition reaction, I'm going to make 2 elements, so I won't have any compounds. Right? So in some of the compounds, or some of the reaction types, I'll have to do this step, and in some I won't. Right? But that's fine. It's still something I should check for. Okay? In this reaction, I do have an ionic compound. It's right here. Okay? And I need to drop and swap it. Iron, as we learned over here, is a 2+, because this was iron, Roman numeral 2, oxide. Okay? So I'll put the 2 here. Okay, and chlorine is always a -1, so I drop and swap. Okay, now that compound is good the way I have it written. Okay, step 5 has to do with the oxygen. Step 5 is check for special elements. That is probably the step that people forget to do most often. Okay. Here's why forgetting that step is crippling in terms of getting marks for this reaction. If I forget to put a 2 on that oxygen over there, this reaction looks balanced, but it's not, because it's not right. Okay, so a reaction like this, a question like this would be a 4-mark question. You would get 1 mark for writing out the reactants. Okay, you would get 1 mark for the products, except you don't have the products right, so you're not getting that mark. You'd get a mark for the balancing, which you're not going to get right because your reaction's not right, okay? And you might get a mark for the reaction type, which you probably get. So you'd lose half your marks for forgetting that step. Is that a big deal? It's a pretty big deal, okay? So this is the step that people forget, and it's the one we have to make sure we don't forget, okay? So I'm checking for special elements. All right, I put a 2 beside oxygen because it's one of our molecular elements. Okay, 6th and final step. Okay, so if I'm going to balance this reaction, okay, I want to start with the biggest number. The biggest number in the reaction is 2, but chlorine already is 2 and 2, so I can't do anything with it yet. Okay, but oxygen is not balanced. There's 2 on the product side, but there's only 1 on the reactant side. So that means I've got to put a 2 here. But when I do that, it gives me how many iron? 2. Okay, so I've got to go over here and put a 2 beside that. And when I do that, it gives me how many chlorine? 4. Okay, so I've got to go over here, and now my reaction is balanced. And now I'm done. Okay. So it's really not a lot different than when you were given the whole reaction. Okay? You just didn't have to really do anything with the pattern. You still had to identify what reaction was happening, but you didn't actually have to do anything with that. Okay? Now you do. That extra step is just know the pattern well enough to figure out who's who in the zoo on the product side, okay, of the reaction. Okay? That's all that's different here. Okay. Does anybody need that anymore? All right. I would like you guys to try question number 3 and question number 4. Okay, so it's written out in words. I want you to write the reactants in formula form, identify the type, predict the products, balance the reaction. Okay, I'll give you a few minutes and then we're going to walk through those ones together. All right, so first step, got to write out my reactants. Okay, so my reactants are magnesium solid, which basically just means it's magnesium by itself. Okay, so I'll have Mg. And nitrogen gas react. What does nitrogen gas look like? N. Right, it's a special element. Okay, something we got to check for when we're writing out our reactants. Okay, so those two things are going to react. So I have 2 elements reacting with each other as my reactants. What kind of reaction starts with 2 elements? Synthesis. Okay. In a synthesis reaction, so now we're on to the part where we do the pattern, okay? What's the pattern for a synthesis reaction? These 2 elements combine to form what? A single compound. Okay, now, magnesium's a metal, and whenever metals are involved, we write them first, okay? So, Mg is going to end up with N. All right, what kind of compound did I just form? It's ionic. What do I have to do with an ionic compound? I'm going to drop and swap. Okay, -3 plus 2. Okay, so we're going to have 3 and 2. Okay, so now I've dropped and swapped. Okay, step 5 is check for special elements. Well, it didn't make any. Okay, I already had one on the reactant side, but I don't have any on the product side, so that box is checked. What do I have to do now? Balance the reaction. Okay, nitrogen's already balanced. It's 2 and 2. Okay, we got a 3 next to the magnesium, so a 3 over here, and we got a balance. Okay, kind of making sense? Right? How many people have done number 4? Okay, let's have a look at that one. Okay, so magnesium nitride just happens to be the stuff we just made, okay, in this reaction here. Right, so we can start out with that stuff, magnesium nitride. If I was starting this from scratch and I didn't just have that compound here, I would do the drop and swap, right? -3 plus 2 because it's an ionic compound, so 3 and 2. All right, it is mixed with water. Okay, since this is an ionic compound, how do you suppose I should write water? H2O or HOH? It actually doesn't matter. There's 2 different ways this reaction can go, depending on how you write water. Okay? If it were me, anytime it's a replacement reaction, I write it HOH. Okay? I write it as H2O if I'm looking at a combustion reaction. Okay? But doesn't matter which way we write it. Okay? There's actually 2 correct answers for this. So let's look at writing it as H2O first, and then we'll look at writing it the other way. Okay. What kind of reaction am I looking at here? Double replacement. Okay, now, is water actually an ionic compound? No, it's not, right? It's a polar molecule, it's a molecular compound. That's why I don't write it this way usually in a replacement reaction. I write it like an ionic compound, HOH. Okay, makes a little more sense when I'm doing the replacement. This can still work. Okay, so hydrogen's the metal, oxygen's the non-metal, magnesium's the metal, nitrogen's the non-metal. What kind of reaction are we looking at here? Double replacement. Okay, so we got two ionic compounds, we got a double replacement reaction. In a double replacement reaction, the metals switch partners. Okay, so that means then that magnesium will be with oxygen, hydrogen will be with nitrogen. Okay, I figured out who goes with who using the pattern of the reaction. I just formed two ionic compounds. What do I need to do with both of them? Drop and swap. Okay, oxygen's a -2, magnesium's a +2. That compound is good the way I have it written. Okay, hydrogen is a +1, nitrogen is a -3. So when I drop and swap, I'm going to get H3N. All right, so now I've got the dropping and swapping done. Do I have any special elements? Okay, so that box is checked. Okay, I didn't have to worry about that part. Now I need to balance the reaction. So what's probably a good idea to start with? Yeah, I can start with the magnesium or I can start with the hydrogen. It probably won't matter which one I start with, but they're the biggest numbers. Okay, so on this side I've got 3 magnesium, but over here I only have 1. So I need to put a 3 in front of magnesium oxide. Doing that gives me 3 oxygens. So I've got to go back over here and make sure I have 3 oxygens. Doing that gives me 6 hydrogens. So I've got to go over here and make sure I've got 6 hydrogens. That gives me 2 nitrogens, and there happen to be 2 over here, so that's good. Now the reaction is balanced. Okay. That making a bit more sense? Right. So it's just a matter of, if I know my reaction patterns, I can get the products. Okay? Yes, there's a few steps you have to check for each time, but they'll go faster and faster the more of these you do. All right, I want you guys to keep, oh sorry, I was going to show you the other way to write that. Okay, so I could have written it like this, Mg3N2 plus HOH. Okay, would have been equally correct to write it this way. But when I predict my products, this is my metal and this is my non-metal. So instead of getting MgO, I get MgOH. And I still get H3N here. Okay, I've got to drop and swap this. Okay, so I get different products. In reality, both of these things happen when you mix magnesium nitride with water. Okay, you actually get some magnesium oxide and some magnesium hydroxide forming in the reaction, so both of these would be correct. Okay, now I haven't balanced that one yet. Okay, I'd have to do this and that and that. Okay. Same balancing. Okay. Yes, this is a 6, but it's still 6 hydrogens, right? So it's still the same numbers. Okay. So 2 ways to do that one. Either way would be right if it was a quiz or a test. All right, I want you guys to try, let's say 5 through 7, and then we'll go over those here in a few more minutes. Okay, so step 1, we got to write out the reactants in formula form. We've got iron, Roman numeral 2 sulfide. Okay, so that's an ionic compound, and the Roman numeral tells me what? It tells me the charge on iron. Okay, so it tells me this is the iron with the 2+ charge. Okay, and sulfur always has a -2 charge. So this compound is okay the way it is written. Okay, and it is reacting with oxygen gas. And they tell you O2 here. Probably on a quiz or a test, I would not give you that. Okay, I would just say oxygen gas, and you would have to remember oxygen is special and needs a 2 to 7. All right. Next step is what? Figure out what reaction it is. Okay, I've got an ionic compound reacting with an element. What kind of reaction is that? Single replacement. Okay, so going with the single replacement pattern, oxygen is a non-metal that will be replacing the non-metal part of this ionic compound. So iron is going to end up with oxygen, and sulfur is going to wind up alone. Okay, I figured out who goes with who. Now I need to do what? Look for special elements. Do I have any? Yep, sulfur comes as an 8. Okay, now what? Before I balance, what do I have to do with the FeO? Drop and swap. It's okay the way it's written, okay, because this is a +2, okay, and this is a -2, okay, so it's already good the way it's written, but it is still something I need to check. I just threw those things together and didn't really look. Okay. All right, now I know all of my compounds and elements have the right numbers next to them. Now I need to balance the reaction. Okay, so what should I start with? Sulfur, biggest number. Okay, so I'm going to go with 8 here. Okay, that 8 gives me 8 iron, so I need to put an 8 there to make the irons work. That gives me 8 oxygens. 4 times 2 is 8. All right with that one? Guys, if you got questions, don't be afraid to ask. Okay, this is probably the toughest thing in this unit. Okay, doing these predictions, getting the reactions right. All right, how many people have done number 6? I can never remember. Molybdenum, M-O, right? Okay, so I've got molybdenum sulfide. So M-O with S. Okay, and the charge on molybdenum is 6. Is that right? Yeah. Okay, so I've got +6 and -2. Here's something that hasn't come up in like 3 weeks. But when I drop and swap this, I get 2 and 6. Do I want to leave it that way? No. What do? Reduce it. Okay? If this happened with a molecular compound where the prefix is set, it's 2 and 6, would I reduce? No. Okay? I only reduce ionic compounds. All right, so when I have that, I'm going to have MOS3. Okay? Reduced it down to 1 and 3 from 2 and 6. All right, it reacts with oxygen gas. Okay, so that's just one of those naming things, guys. We haven't done much naming. We haven't looked at a situation like that for a while, but it's one of those things we have to remember. Okay, reacts with oxygen gas. We're looking at a single replacement again. Okay, so oxygen is going to replace the sulfur just like it did, okay, in the previous reaction. So molybdenum is going to end up with oxygen. Move. Okay, and sulfur is going to wind up alone. And when sulfur winds up alone, it's an 8. Okay, what do we have to do with move? Drop and swap. Okay, same situation. You got a +6 and a -2. So when I drop and swap, I'm going to get 1 and 3. Okay, now I need to balance. Am I possibly going to have some large numbers? Okay, I've got 3 sulfur over here. I've got 8 over there. What's the lowest common multiple of 3 and 8? 24. Okay, so I need to put a 3 here because 3 times 8 is 24, and I need to put an 8 here because 8 times 3 is 24. That gives me 8 molybdenums, so I need to go over here and make sure I've got 8 molybdenums or molybdenum. Never pronounce it right. Okay. And then that's going to give me 24 oxygens. So I needed 12 there. Okay, so that one was tricky on the balancing part. Okay, how many people have done 7? Okay, so we got molybdenum oxide, which we happen to have right there, so we can save ourselves a little bit of work. MOO3 reacts with hydrogen gas. Reaction we're looking at. Still single replacement. Okay, so we've had a lot of single replacements. Why would I put so many single replacements on here? Yeah, you basically have to do everything. In a single replacement reaction, you're going to possibly get special elements. You're going to have to drop and swap. You're going to have to do all those steps that were in the list that we made there before. You don't have to do that for a combustion reaction, per se. Okay? All right, so I got a single replacement reaction. Hydrogen is going to act as a metal here. Okay, when it's by itself, hydrogen typically acts as a metal. So it's going to replace the molybdenum, which means I'm going to have hydrogen with oxygen and molybdenum. Hello. Okay. Do I have any special elements? No. What do I have to do with the H and the O? Drop and swap. What am I probably going to make? Water. Okay. Alright, now I need to balance the reaction. Oxygen is out of balance right now with a 3. So I'm going to go over here and make sure I have 3 oxygens. That gives me 6 hydrogens. 3 there. Everything else should be good. Alright, I'm going to give you guys a little break because we've been working on that pretty steady here. So, if you need to use the bathroom, get a drink or whatever, 9:28, we will resume what we are doing. Okay, so you got 5 minutes to answer any texts you need to answer or anything like that. Okay, if you're going out to the hallway, make sure you're quiet so you don't disrupt anybody's class. Yeah? Oh, actually, but it's molecular. Yeah, this is not a typical reaction type, which is why I gave you both the reactants and the products for that one.
Oh.
Yeah, so you didn't actually have to pick that one. I gave you reactants and products just because it's not a typical.
Okay, so what would you make balance of?
Okay, so. Okay, we got copper 1 sulfide. Okay, reacting with oxygen gas. Okay, and that's going to produce copper 1 oxide and right. Okay, so the tricky part here is getting the oxygens to work because they're in 2 places, kind of like they are in a combustion reaction. Okay, so on this side I've got an even number of oxygens, but on this side I have an odd number. Okay, what's the quickest way to turn an odd number into an even number? Exactly. So now I don't have an odd number of oxygens anymore, right?
Yeah, and then just to fix the copper and sulfur, we'd add 2 to the copper, and the hydrogens would also add 2.
So I've got 4, right? And then I've got 2 here. Okay, so now I've got 4, 6.
Okay.
Yeah,
That makes more sense.
it's tricky.
Yeah.
Right? That's about as tricky as balancing is going to get.
Yeah, looking at that now, that's a little bit easier.
Yeah. So anytime you run into, and you're going to run into it actually fairly often, we just call it the odd-even problem. You got an odd-even problem? You double something. Double the odd, right?
That makes sense.
Okay. Mm-hmm. Okay, so what I've done here, guys, in Google Classroom is I have posted the keys to all of the reaction worksheets that are in your workbook. Okay, this one included. Right, so the one we're working on is actually a worksheet out of your digital workbook. Right, so if when you're working on these, you want to check and see if you did it right, you can just refer to the key just in case it's not one that I've done up on the board. Okay, so what I want you guys to do right now is I want you to try 11, 12, and 13. Don't worry about 8 and 9 for right now. Okay, look at 11, 12, and 13, okay, and see how we do with those. All right, so on number 11, okay, we have aluminum, okay, reacts with iodine. Okay, anything I need to check there in the reactants? Iodine, okay, special element, so it comes as a 2. All right, I have my reactants written out in formula form. Step 1 is done. What kind of reaction am I looking at? Synthesis, okay, so that's step 2. Okay, I've identified that this is a synthesis reaction, and in a synthesis reaction, step 3, I'm going to use the pattern to create my products. A single compound involving the two things that reacted with each other. All right, what kind of compound am I forming here with aluminum and iodine? Ionic. Okay, I have to drop and swap this ionic compound then. Aluminum has a 3+ charge, iodine a 1-. So I'll have AlI3 as my compound on that side. And now I need to check for any special elements. None. So now I can move on to balancing. Okay. What should I balance first? Iodine. Okay. Lowest common multiple of 2 and 3? 6. Okay. All right. So I'm going to put a 2 on that side, a 3 on this side, and a 2 there to balance the aluminum. And that should be good. Questions on number 11? How many people have done 12? Okay. Are we starting to feel like pretty good about this? Like, okay. All right. So number 12, I've got silver nitrate. So I've got Ag, okay, NO3. Actually, I don't need the brackets, so I'm not going to write them. Okay. Silver nitrate, AgNO3 is going to react with copper 2 chloride. Okay, so that's the copper with the 2+ charge. Chlorine is a -1, so when I drop and swap, I'll get this. Okay. What kind of reaction is that? Double replacement. Okay, in a double replacement reaction, I swap the metals. So silver ends up with chlorine, copper ends up with nitrate. All right, I just made 2 new ionic compounds that both need to be dropped and swapped. +1, -1. That compound's good the way it's written. Okay, copper is the copper with the 2+ charge, because that's what it was on the reactant side, so that's what it is on the product side. That won't change. Okay, and nitrate's a 1-. So what do I have to do with this compound?
Put brackets.
Right, put brackets around the nitrate. All right, so now I've got all my products dropped and swapped. There aren't any special elements to worry about, so now I can balance the whole reaction, starting with probably nitrate. Okay, there's 2 over there. Now there's 2 over here. There's 2 silver. Now there's 2 silver on both sides. 2 chlorine, 2 chlorine, 1 copper, 1 copper. Okay. How many people have done 13? All right, so for number 13, I've got barium chloride, and it's reacting with ammonium carbonate. Okay, actually I probably wrote those 2 close together. All right, so I've got 2 ionic compounds, and what have I not done with either one of them? I haven't dropped and swapped either one of them. Okay, barium is a 2+, right? Yeah. Okay, and chlorine's a -1, so 2+, -1, we drop and swap, we got that. Ammonium is a +1, carbonate is a -2, which means ammonium gets the brackets, and a 2, and carbonate doesn't. All right, 2 ionic compounds are reacting. What kind of reaction is that? Double replacement. Okay, so the metals are going to switch places. Ammonium is the metal in ammonium carbonate because it was the thing that was positively charged. Okay, it's going to switch places with barium. So barium is going to wind up with carbonate, and ammonium is going to wind up with chlorine. All right, so I just made 2 new ionic compounds. What do I need to do with them? Drop and swap. Okay, -2, +2. That one's good. +1, -1. That one's good. Okay, they're already just happened to work out. They were already dropped and swapped. Now I need to balance. I can start with either chlorine or ammonium. It won't matter which.
I'm not answering.
Oh, okay. If I put a 2 there, that takes care of both the ammonium and the chlorine, and now my reaction is balanced. Okay. All right. Try those ones.
So if you have a polyatomic ion and non-metal, does the polyatomic ion always go through?
Yes, the only time that's going to happen is with ammonium. Ammonium's the only positively charged polyatomic ion we work with. Yeah, so it's the only one that acts like a metal. Okay, let's just have a look at a few of these to make sure you're getting everything here. You can check your answers here. So for number 14, I've got iron 2 chloride reacting with sodium phosphate. Okay, so iron with chlorine, and this is the iron with the 2+ charge. Okay, that's what the Roman numeral tells me. Okay, so we got FeCl2, and it's reacting with sodium phosphate. So that's Na, which is a +1, with PO4, which is a -3. Yes? Okay, so that's going to mean Na3PO4. All right, so I've got my reactants written out. They're dropped and swapped. What kind of reaction? Double replacement. Okay, so we're going to swap the metals. Sodium and iron are going to switch partners. Iron is going to end up with phosphate. Sodium is going to end up with chlorine. Okay, I just made 2 new ionic compounds that need to be dropped and swapped. Well, actually, NaCl doesn't. That's fine. It's +1 and -1, so it's good. Okay, but iron phosphate does. This is the iron with the 2+ charge. Phosphate's a -3, so we're going to have a 3 here, a set of brackets, and a 2. And now we need to balance the whole reaction. What should I probably start with? Okay, 3 is my biggest number. But in general, what I do if I've got 2 things that are the same number, I go with the one with the biggest charge. Okay, because it tends to have more of an effect on the numbers. So I'm going to start with iron because it's a 2+, but it's got 3. Okay, so I'm going to say I got 3 irons over here. So I'm going to go over here and make sure I've got 3 irons. Okay, that gives me 6 chlorines. So I got to go over here and make sure I've got 6 chlorines, which gives me 6 sodiums. So I'm going to put a 2 here. That gets my 6 sodiums and 2 phosphates, of which there are 2 over there, and my reaction is balanced. All right, let's have a look at number 15 as well here. So I've got zinc oxide, okay. So Zn with O. This is a -2, and that's a +2, so that compound is okay like that. And hydrogen chloride. Okay, 2 ionic compounds. So this is a double replacement reaction. Hydrogen's acting as the metal here. So these 2 things are going to react. Zinc is going to end up with chlorine. Hydrogen's going to end up with oxygen. All right, I just made 2 new compounds. What do I have to do with both of them? Drop and swap. Okay, so +2, -1. So we're looking at ZnCl2. Okay, and +1, -2, H2O. Okay, and then we got a balance. 2 there should take care of all of our problems. All right, questions on any of those? Questions on any of the other ones? All right, I'm gonna give you a few more minutes and then I'll go through a couple more and then we'll call it a day. 16 here, guys. So on number 16, there's one thing here that happens once in a while, and we do need to address it, okay? Because it's something that can give you a bit of an issue. Okay, so on number 16, I've got copper 2 sulfate, which is CuSO4. This is a -2, that's a +2. Okay, it's reacting with iron solid. Okay, this is a single replacement reaction. Our element is a metal, so it's going to swap out copper, and it's going to end up with sulfate. Copper's going to end up alone. That part's pretty straightforward. Here's the problem. Iron has more than one possible charge. And there's no way to know which one it is the way the reaction is written, because iron was an element with no charge on the reactant side. Okay? It's never going to say iron 2 reacts with, because it only has that 2+ charge when it's in an ionic compound. Okay? So since it started out as an element, we have no way to know which one it is. Here's the good news. There is a more common charge. And it's usually like quite a bit more common. For iron and for any of your multivalent metals, the first number listed is the more common charge. So if there's no way to know which one it is, you go with the first one listed. Okay? For iron, that's which one? 2. Is it 2 or 3? 3, right. Okay. So the more common charge for iron is 3+. Okay? So now when I drop and swap, okay, I got a 2- here, so I got Fe2SO4 3. Okay? That's what I have to do in that situation. So it does come up once in a while when you have a single replacement reaction involving a multivalent metal as the element. You have to go with the more common charge because there's no way for you to know otherwise. Okay, we're going to call it a day there. Everybody can mask up and clear off their desk. I'll come and spray them down. You guys can wipe them off.